So welcome you all to this tutorial session, and a very good morning to all of you.
Good morning, sir.
So yeah, so now house is open. You can ask anything under the sky. Any doubts you have? Don't have any doubts, eh?
Sir, in assignment number 3, question 2, part A, for P equal to 1, I cannot deduce the form of the estimator.
Assignment number 3, right?
Yes, sir.
Let me just see. This is the assignment 3?
Yes, sir.
You're saying problem number?
2A for P equal to 1.
Okay. So this is X1, X2, Xn be IID from a Lebesgue PDF, this thing. Both are unknown, right? So this is, now this will belong to the location scale family, right? PDF can be written as 1 upon sigma to power n into f of x1 minus mu by sigma, x2 minus mu by sigma, and xn minus mu by sigma. Is that okay?
Yes, sir.
Where fx is nothing but e power minus x if x greater than 0 and 0 otherwise. So this belongs to a location family, location scale family. Now we have seen that location scale family is invariant under affine group of transformations. That means transformations of the type ax1 plus b, ax2 plus b, and axn plus b. Right. Here I can talk about estimation of mu and estimation of sigma, but the problem which you are talking about is estimation of a sigma, right? And we have seen any affine estimator, affine equivalent estimator, what would be its? First of all, this loss is invariant, right? Because it is of the type W of A by sigma, right? From the notes.
Yes, sir.
Your estimation problem is invariant.
Yes, sir.
Estimator delta is invariant if and only if for a given delta naught, if I choose delta naught to be a fixed estimator, which is scale invariant. No, first of all, what is a scale invariant estimator? A scale invariant estimator is any estimator which satisfies delta of ax1 plus b or bx1 plus c, bx2 plus c,
X2 plus
c
equal to b to the power r delta x1, x2, xn.
b to power r. Here I am just interested in estimator of sigma, so b into delta.
B. Yes, sir.
Now this can be alternatively written as delta is invariant if and only if delta is same as delta naught in divided by u of w1, w2, wn minus 1, right? For some.
Yes.
So incidentally, in this case, g bar acts transitively. These exponential family, so there is a complete sufficient statistic, which is x1 and summation xi minus x1. So in this case, that u star will not depend on w, right?
Yes, sir.
That would depend on u, which minimizes the expected risk under this loss, and you're saying p is equal to 1, right? So I am just coming to that now. So I've summarized how does the solution would look like. Problem number 2b. So this is what I'm saying. Your loss function is this. Everything is invariant. There is a complete sufficient statistic delta naught, which I have chosen to be because it is a sigma, right? So a natural estimator of sigma I can choose as summation I is equal to 1 to n xi minus x1 because its distribution is known to me, and I know that this delta naught satisfies delta naught of bx1 plus c, bxn plus c, which is same as summation I is equal to 1 to n bxi plus c, minus minimum of bx1 c plus c, bx2 plus c, and bxn plus c. But b is positive and c is common. So that would be same as b of minimum of x1, x2, xn plus c. Now this c gets cancelled. B is positive. B is anyway common, so that will come outside. So that becomes b times summation I is equal to 1 to n xi minus x1. which is same as b times delta naught of x1, x2, xn. So it is a scale invariant, a fine invariant estimator of sigma, right? So any other estimator would be of the type delta naught, this estimator divided by u of w1, w2, wn minus 1. But here G bar acts transitively and there is a complete sufficient statistic. So the MRE would be given by delta naught by U star. U star is not going to depend on W because of Basu's theorem, because there is a complete sufficient statistic and W is ancillary. And what does U star minimizes? U star minimizes expected value of delta naught x by U minus 1. Is that okay? Since G bar acts transitively on this, you can take mu to be 0 and sigma to be 1, right?
Yes, sir.
So now I have to just minimize what is the minimizer of this quantity. For that, I need to know what is the distribution of delta naught x. From your earlier course, you must have seen that delta naught x has a gamma distribution with n minus 1 as a shape parameter and scale parameter as 1 because sigma is given to be 1. Is that okay?
Yes, sir.
You know from a, this can also be written as a chi-square, right? Gamma, there is a relationship between gamma and chi-square. So I'm writing all this as gamma n minus 1, whose density is basically this. This is the density of gamma n minus 1, e to power minus t to power n minus 2 by factorial n minus 2. Is that okay?
Yes, sir. Yes.
So I'm trying to write down what is a psi u, which is 0 to infinity mod of t by u minus 1. Now u has to be positive, right? This u has to be positive. So what I do is I break it into, because I have to break this modulus. I have to get rid of this modulus. I can get rid of this modulus only when I know whether t is less than u or t is greater than u. Right? Now u I'm taking to be positive. So when t is less than u, that means t by u is less than 1. So this modulus would be 1 minus t by u. Is that okay? E to power minus t to power n minus 2 by factorial n minus 2 by 2. And this would be other way, t by u minus 1 when t is greater than u. So that is the reason why I have broken this integral into two parts, depending on whether t is less than u or t is greater than u. Is that okay? So I have written out 1 minus t by u and t by u.
Yes, sir.
Right? So this is what it becomes. So I now try to just take the derivative, right? So I want to take the derivative of this. Now so it is a composite function. So when I take the derivative of this, what I do is I put t is equal to u over here and derivative of u is 1 only. So when I put t is equal to 1, this becomes 0. So that doesn't contribute anything, right? So that means now I take the derivative of u inside. So that is becomes 1 by u square into t. And t with this will become t to power n minus 1. Factorial n minus 2 comes outside. So 0 to u e to power minus t to power n minus 1 dt. Is that okay?
Yes, sir.
Because it is a composite function, so u is coming through this integral as well as inside the integral. So I first do it with respect to this. So when I put t is equal to u over here, derivative of t is equal to u will give you 0, right? So that doesn't contribute anything. So the only derivative would come through this. Is that okay? So that is t by u square.
Yes, sir.
So that is one. Now similarly over here, first will come with respect to this. When I put t is equal to u, it becomes 0. So the only thing will come through this, which is minus t upon u square, but t with tn minus 2 will give you tn minus 1. So this is what it comes. So I see increasing and decreasing behavior of this function. So this is greater than 0 or less than 0. U square vanishes, factorial n minus 2 vanishes, so 0 to u e to power minus t to power n minus 1 dt is greater than or less than u to infinity e to power minus t to power n minus 1 dt. Right? Now note that this again is a density of a gamma except a normalizing factor, which is same as this. And it is a gamma n, right? So if I divide both the side by gamma n, which I can do because there is an equality, I get this quantity as a PDF of a gamma n, right? So this is same as PDF of gamma n, GNU, distribution function of gamma n at the point u. That is what it becomes. And what does this become? Is greater than or less than? I have put 1 upon gamma n, I have divided by both the sides. So it is a PDF of a gamma n. So
1 minus GNU.
Greater than u. So that is same as 1 minus GNU. Greater than or less than. where GNU is the distribution function of gamma and distribution. What does that mean? GNU is greater than half or less than half, right? But GNU is strictly increasing function. So GNU is greater than half means U is greater than GN inverse half, or U is less than G inverse half if it is less than. So that means U is greater than or less than GN inverse half. And what is the GN inverse half? That is a median of gamma and distribution, right? So that means your psi U is increasing if U is greater than median of the gamma and distribution, which is Mn, and it is decreasing before that. So where the minimum of psi U would be?
The median.
Median. So that means Mn, which is a median of a gamma and distribution. So this says that MRE would be, this was your delta naught, and this is U star. U star is nothing but median of a gamma and distribution. Is that okay?
Yes, sir.
So the only thing which you needed here is distribution of summation
xi minus x1.
That is the one thing which you need. You needed a differentiation of a composite function of the type 0 to U. Yeah. So you needed a differentiation of a composite function of this type, right?
Yes, sir. The answer for part C, it is required to find that MRI of mu plus sigma. So, so if we can estimate mu and estimate sigma, can we conclude something from that?
No. I have said your whole estimation problem depends on the group of transformations you are considering and the estimate, right? Because your G tilde, what G tilde you should choose? G tilde is the group of transformation acting on the action space. That depends on what your estimate is, right?
Yes.
But okay. So just separately finding MRI of mu and separately finding MRI of sigma and adding that will not help. You have to look at what is the class of invariant estimators for mu plus sigma. Right?
Okay.
So you go step by step. Here anyway, P remains the same. P does not depend on the estimate. P is the exponential. So P remains invariant under affine group of transformations. Induced group of transformations on the parameter space also remains the same because it depends on P only. So what is the induced group of transformation on the parameter space? G bar BC of mu sigma is how much?
B mu plus sigma B sigma.
B mu plus sigma and B sigma.
B sigma.
Now, so what is happening under G? So I have to guess what is my G bar delta BC, right? That okay?
Yes.
Now, your mu sigma has gone to mu plus sigma, right? So under G bar BC, where does mu sigma goes to? B mu plus sigma plus B sigma, right?
B sigma.
Right? Mu goes to B mu plus sigma and sigma goes to B. So everything goes to B of mu plus sigma plus C.
Yes.
Which is same as B times estimate in the earlier problem. So that means B times the action I was taking before, A plus C. So that means it suggests that I should take my B G tilde to be BA plus C. And then that is what we'll do. Let's try to see. Part C you are saying, right? Yeah.
Yes.
So this is what I'm saying. Consider the affine group of transformation GBC, where it is the same BX1 plus C, BXN plus C. P is invariant because P is invariant for all the three problems. P is the same. G bar, which is the induced group of transformation on the parameter space, that also remains the same, B mu plus C. It is only the G tilde which changes, and G tilde depends on what you are trying to estimate, your estimate. So what I am trying to guess is what should be my G bar group of transformation on the action space. So under G bar BC, mu goes to B mu plus C and sigma goes to B sigma. So where does mu plus sigma goes to? Mu plus sigma would go to B times mu plus sigma plus C, which is same as B times earlier estimate plus C. So that is why my G tilde BCA would become BA plus C. Now I have to see whether my loss function is invariant or not, because that is one important aspect. If the loss function is not invariant, your estimation problem is not invariant, right?
Yes, sir.
So I see what is LG bar BC theta and LG tilde BCA. Original loss was A minus mu whole square by sigma square. A has become BA plus C under G bar BC tilde A. What does G bar BC theta has become? Here mu has become B mu plus C plus B sigma.
Yes.
Whole square by sigma square, B square, B sigma whole square. So CC gets cancelled. It becomes A minus mu plus sigma whole square by sigma square. BB also gets cancelled, which is same as L theta A. So your loss is invariant.
Invariant.
Loss is invariant, so estimation problem is invariant. Estimation problem is invariant, so you can consider only invariant rules. Is that okay?
Yes, sir.
Now here G bar acts transitively. Why? There are two parameters with us, BC, and there are only, two parameters BC, and only parameters are also two, mu and sigma. So given any mu1 sigma 1 and mu2 sigma 2, I can relate them by G bar BC transformation, right? You'll get one.
Yes.
So G bar acts transitively.
Hmm.
So I try to look at what should be the form of a invariant rule. Delta belongs to Di if and only if delta of G bar BCX is same as G bar BC tilde delta X, right? What does that mean? But this is what exactly was the case for the location. That means G of delta of Bx1 plus C. Actually, this should be G of BC, not G bar. That means delta of Bx1 plus C, Bx2 plus C, Bxn plus C should be same as B times delta of X1, X2, Xn plus C. But that is exactly was the form of a estimate of a mu, right? So what it says is, let delta naught and delta 1 be the fine equivalent estimator of mu and sigma respectively, then any invariant estimator can be written as delta naught x minus mu star w of delta 1 x. Is that okay? Because that is what exactly you saw in the location case also.
Yes, sir.
G bar acts transitively. I take delta naught to be x1. So delta naught of bx1 plus c, bx2 plus c, bxn plus c would be same as b of delta naught of x1 x2 plus c. So it is a fine equivalent estimator of mu. This I take to be delta 1. This can be taken as a fine equivalent estimator of sigma because delta of bx1 plus c, bxn plus c, cc would get cancelled. B would be here, B would be here, that would come outside, and B of delta naught x1 x2 xn plus c.
Yes, sir.
They are a function of a complete sufficient statistic. So by Pascal's theorem, this U star W and W is ancillary. So this U star W is not going to depend on W. So MRE is basically x1 minus U star of summation xi minus x1, where U star minimizes this quantity. Is that okay?
Yes, sir.
And what is that? X1 minus U times summation I is equal to 1 to n xi minus x1 minus 1 whole square. Why 1 over here? In the location case, 1 was not coming because your estimate was only there mu. Here estimate is mu plus sigma. So when you consider this loss function, you have to consider this at mu is equal to 0 and sigma is equal to 1. So whatever is the estimator minus 1 would come. Whereas in the location case, there was no sigma, so only mu is equal to 0 and 1 gives you this as 0 only, a square was coming. Right?
Yes, sir.
So that is what it has happened. This is a quadratic equation in U, right? So you see, its double derivative is would be positive. Expected value of summation I is equal to 1 to n xi minus x1 whole square, positive. So minimum would be where derivative is 0. Derivative is 0 when this U go outside. So x1 minus 1 summation I is equal to 1 to n xi minus x1 divided by this square. Is that okay? Just take the derivative and put it equal to 0. I know from my last theorem, last course, that x1 and summation xi minus x1 are independent, right? In the exponential case, so same as expected x1 minus 1, e01 summation xi minus x1 divided by e0 summation xi minus x1 whole square. Under mu is equal to 0 and sigma is equal to 1, just now we have seen that summation xi minus x1 is gamma n minus 1. Right? So it is gamma n minus 1 expected value and gamma n minus 1 whole square. Expected value of gamma n minus 1 is n minus 1. Expected value of gamma n minus 1 whole square is nothing but n into n minus 1. What is expected value of x1 minus 1? x1 is exponential. Right? x1 is exponential with mean as 1 by n. So x1 minus 1 by n minus 1. Is that okay?
Yes.
So you get this as minus n minus 1 upon n square. So your MRE of mu plus sigma is x1 plus n minus 1 upon n square, summation xi minus. Is that okay?
Yes, sir.
Yeah. Any other doubt here? So everywhere, you see, finally, the first thing that you have to check is whether your group of probability distributions are invariant under G or not. If that is invariant, then you have to identify G bar. Then depending on what you are estimating, you can find G tilde. So G tilde every time you have to guess. And then you have to see whether your loss function is invariant or not. If loss function is invariant, your problem is invariant, then you can look at into class of invariant rules. In many situations, G bar would act transitively. So your risk will not depend on mu and sigma. So then risk, you have to only minimize the constant risk. Now many situations that W statistics or D statistic will be independent of that conditional thing. So you can get the exact MRE, right? That is what the whole approach is. Yes, any other doubt?
Sir?
Yeah.
Sir, can you explain the solution 4?
Solution 4, let me just first see what is the problem. I think this I did in the class, no?
Sir, in class it was for sigma square.
No, mu only also. That W0 convex, if it is convex, then it is exactly the same, no? You see, I did this for the sigma known case, right?
Yes, sir.
Right? If you recall?
Yes, sir.
So sigma unknown case would be exactly the same. Let us try to see. Problem number 4 you are saying, right?
Yes, sir.
Problem?
4.
Oh, I missed problem number 4 it looks like. Huh? How did I miss problem number 4? Let me see. It is what you are trying to estimate here?
Sir, nu. Estimation of mu.
I think I have messed up with this numbering possibly. Let me just check. This is exponential, that is okay. This is part second, possibly mu plus sigma or what? Oh, this is, I think, no, yeah, this is exponential, I think mu plus sigma. This is mu plus sigma. You are saying problem number?
4.
I think this is what the problem 4 should be. Because this is what it is coming now. The estimation problem is invariant under a affine group of transformations, right? Because normal mu sigma. So bx1 plus c, bx2 plus c, bxn plus c as IID normal. With affine group of the induced group of transformation on parameter space as g bar bc theta as b mu plus c and b square sigma square, right?
Sir, one more thing, sir. Sir, about the SO, about the guessing of G tilde X, sir. Sir, sometime I did not able to guess it properly and did not able to proceed that question.
You see, you are dealing with the two problems. One original problem, one transform problem. So make a one line, write down what is the original problem, what is the transform problem. Write down what you are trying to estimate in the original problem, what you are interested in estimating the transform problem. Now, in the case of mu plus sigma, what was happening? Initially, I was interested in estimating mu plus sigma.
Yes, sir.
Transform problem, what has happened under G bar BC? Mu has become B mu plus C.
Yes, sir.
And sigma has become B sigma.
Yes, sir.
So the sum of the two has become B mu plus C plus B sigma. Is that okay?
Yes, sir.
So it has become B of mu plus sigma plus C. But mu of plus sigma was the original estimate. So that means your A has transformed to BA plus C. Because earlier you were estimating mu plus sigma. So if Xn earlier was A, now the Xn should be BA plus C. Because mu, is that okay?
Yes.
G tilde AC is BA plus C. If you are interested in estimating sigma under G bar BC or sigma to power R, under sigma to power R, your estimate is suppose sigma. So under G bar BC plus mu, sorry, under GBC, G bar BC has become B mu plus C and B sigma.
Yes, sir.
That means sigma has become B sigma. So sigma to power R has become B to power R into sigma to power R. But sigma to power R was my original estimate. So that means it would have been the original Xn. So that means now my transformed Xn should be B to power Ra. So G bar BC A should be B to power Ra. It should not depend on C. That is what it is. So everywhere it is straightforward, right? You just have to.
Oh.
So here you are interested in estimating mu. So B mu plus C and B sigma has become, sorry, mu sigma has become B mu plus C and B sigma. That means mu has become B mu plus C. If you are estimating mu.
Sir, yes, sir.
Mu was the original estimate. So now Xn, that means original Xn should become BA plus C. So that means G tilde should be same as BA plus C. Is that okay? If you are estimating mu.
Yes, sir.
And that is what it says. Delta naught is equal, wait for delta is equivalent if delta naught satisfies this quantity. Equivalently, if delta naught is any affine equivariant estimator of mu and delta 1 is any affine equivariant estimator of sigma, so I take delta naught to be x bar, which satisfies bx delta naught of bx1 plus c, bx2 plus c, bxn plus c is as b of x1, x2, xn plus c. This is an estimate of sigma. Then any affine equivariant estimator would be of the type delta naught x minus u times delta 1x. This is what we are doing in the class.
Yes, sir.
MRE would be which minimizes this.
Which minimizes this. Yes, sir.
Now here in the affine equivalent location scale family, I know that affine group of transformation acts transitively. So the risk is not going to depend on mu and sigma. Not only that, your delta naught and delta 1 both are function of complete sufficient statistics x bar and summation xi square. So that will not also, that conditional distribution will also not depend on W. Normally it should depend on W, right? U star W. But because complete sufficient statistic is there, so it will
come out of the.
So that means U star minimizes E01 W of delta naught x minus U times delta 1x, which is same as this.
Yes.
Okay. Now, to show that minimum is attained at 0, W is given to be convex, what you should show? Psi is even.
Yes, sir.
If I can show that psi of u is same as psi of minus u, then minimum would be attained at psi 0. The way we did. So I try to show that.
Sir, it is given in the question that our loss function is even. So can't we write directly?
No, how it is expectation.
Oh, okay, sir.
It is an integral. So your original function has been transformed, right? It is not the original function.
Okay, okay.
Is that okay?
Yes, sir.
So you have to show that psi of u is same as psi of minus u. So this is same as psi of u is same as this, which is same as x bar minus u, this thing. Now I know that distribution of x bar and summation xi minus x bar are independent. Right? Distribution of x bar and summation xi minus x bar are independent.
Yes.
And under mu is equal to 0 and sigma is equal to 1, x bar has the same distribution as minus x bar.
Yes, sir. Yes. Yes, sir.
Now, since they are independent, x bar and summation xi minus x bar, this distribution would be same as marginal of this into marginal of this. Is that okay? This joint distribution would be same as marginal of x bar into marginal of this.
Yes, sir.
But
Yes.
marginal of x
They
bar
are
is same as
independent.
marginal of minus x bar
Yes, sir.
into distribution of this.
Yes, sir.
But if x bar and they are independent, then minus x bar and they are also independent. So that means marginal of minus x bar and marginal of this would be same as joint distribution of minus x bar and this. So it is x bar and summation xi minus x bar has the same distribution as minus x bar and square root of summation xi minus. Note that here the independence of the two has played an important role. Because of independence only I was able to say that joint distribution of x bar, and because here I am talking about joint distribution. So I am saying joint distribution of x bar and this is same as product of marginals. So that is same as product of marginal of x bar into product of marginal of this. But x bar has the same distribution as minus x bar has a marginal distribution. So this marginal distribution would be same as marginal of minus x bar into this.
Yes, sir.
Minus x bar and they are further independent. So that is same as a joint distribution of minus x bar and this. So here independence is playing a role. Otherwise, in general, if x has the same distribution as minus x, you cannot say that x and y will have a same distribution as minus x and y. Is that okay?
Yes, sir.
Independence is there, then you can say. Because then you can write down joint as a, is that clear?
Yes.
That point I wanted to
Yes, sir.
so that
Yes, sir. Yes, sir.
clear to you. Now, if that is the thing, then here, wherever x bar and they are coming together, I can replace x bar by minus x bar and I can keep these as it is. Because their distributions are same. Because
Yes, sir.
if x has the same distribution as y, then expected value of x is same as expected value of y. Or expected value of psi of x is same as expected value of psi of y for any function say. So I have replaced x bar by minus x bar. This remains as it is because when I talk x bar and they have the same distribution, so I have to replace x bar and this by minus x bar and this. So that means I can replace x bar by minus x bar, but this I can have to remain as it is. And that is what I did. This has remained as it is. But my W is even. This is same as W of x bar plus U of this thing. But what is that? That is nothing but psi of minus U. That is same as psi.
Yes.
So psi of U is same as psi of minus U. W is convex.
Then it will be minimum at 0. Okay, sir. Yeah. Yeah. Okay.
Okay.
Yes, sir.
Independence has played role, and that is why they are turning out to be. Yeah. Any other doubt? So there have been problem 4. I think there is some have missed problem. So I did problem 1, problem 2. Let me just check. Oh, problem 3 I have written twice. So that should be problem 4. Yeah. Any other doubt?
Sir, can you show some solution for bivariate case?
Yeah, tell me.
For bivariate case, how to proceed?
Which bivariate case?
Sir, as in problem number 6.
Problem number
6.
6. Let me just take a break for a while. I'm just coming back. Huh? I'm just
Yeah,
coming.
okay, sir. Okay, sir.
Somebody is there. I'll just.
এই অর্থক বুঝছিস ভাই?
হ্যাঁ বুঝছি তো।
ভাই কোশ্চেন শুনে রে, আমি তো কিছু করিনি। আমি জানি সিনিয়রের অ্যাসাইনমেন্ট দেখলাম কোনটা করেনি আর সেটা শুনলাম। আমি তো কিছু মাথা গুড়াই
বাই
জানতাম।
দ্য ওয়ে এটা কিন্তু রেকর্ড হচ্ছে, ঠিক আছে? বেশি বকিস না।
একটু সাবধানে।
রেকর্ড হলে বুঝবে কে?
সংকেত
আমার
तू
তো
तो
সকাল
एकदम
সকাল এত ভালো লাগছে না
बिंदास
দেখে।
पढ़ रहा है।
क्या
अभिलाष को देखो एक बार कैसे कैमरे की तरफ हाँ करके देख रहा है।
ये सब मत करो, रिकॉर्ड हो रहा है भाई।
अरे ये तो क्लास ही है ना, तो क्लास में क्या तुम बात नहीं करते?
वही बात है। संकेत तूने क्या फिर से बाल उड़ा दिए?
तो आ गए।
एंगल से इंस्पायर हो गए क्या?
एंगल्स इंस्पायर्ड सभी लोग।
জামাটা কিরকম বল?
দো উঠে আছে আমার তো এটা দেখেই মানে কি ইন্সপিরেশন তুই চিন্তা করতে পারছিস না।
এমন
জামাটা বল
করছিস?
কিরকম জামা?
আর
এই জামা জামা করছে কেন? ওই বাবা এই করিস না, এটা করিস না।
কি কি হলো?
বলছি দাদা।
সপ্তর্ষিকে একবার ভিডিওটা অন করতে বল।
ও বাবা, ও ও ফোনটা একদিকে, ল্যাপটপটা একদিকে, ও একদিকে।
সপ্তর্ষি তো কিছু মানে ঘুমিয়ে গেছে নাকি?
হাই চান্স ওটাই।
না না, আমি জেগে আছি। ও এটা কেবল জাগলি মনে হচ্ছে।
বাজে কথাগুলো কেন বলিস?
আরে ক্লাস কিন্তু রেকর্ড হচ্ছে কিন্তু।
কি আর করবে, খুব বেশি হলে দোয়াতে একবার যাব আর কি, একটু রিফ্রেশমেন্টও হয়ে যাবে বাড়ি থেকে। দোয়া
ডোয়া কি সব ভিডিওগুলো দেখে নাকি বসে বসে রেকর্ডেড লেকচার?
এত সময় আছে ওদের কাছে?
আমি জানি না, এমনি বললাম যে খুব বেশি হলে ডাকবে।
রেকর্ডেড ভিডিও মানে স্যারও দেখবে না, আবার ডাইরেক্ট আপলোড করবে।
ডাকলে বলে দেবো যে অফলাইন ক্লাসের বিদ্যাদানের জন্য কথা বলছিলাম।
ব্যাপারটা হচ্ছে হ্যাঁ, মানে আমরা তো এমনি যখন অফলাইন ক্লাস হয় তখন তো আমরা গল্প করি, তো বাড়ি থেকে তো এই গল্প ব্যাপারটা হচ্ছে না। বাড়িতে রেস্ট্রিকশন, মানে
ক্লাসে ধরে এরকম যদি স্যার বেরিয়ে যেত তাহলে আমরা তো কথা তো বলতাম।
কি করব না করব, দোয়া আর কি এই ভিডিওটা দেখেও বুঝতে পেরে যাবে যে উত্তরটাও এরা কি দেবে না দেবে। संकेत सोच रहा है ये बोल क्या
आती होगी तब तो ठीक है। संकेत अभी देख रहे रिकॉर्ड हो रही है क्लास, छोड़ो कुछ नहीं बोलो।
हाँ वो सेफ जोन में खेलता है ऑल टाइम।
अरे हम
विलास भगवान को एक बार कॉल दे दो ना
यार। কতক্ষণ হবে यार?
এইসব কন্ট্রোভার্সিয়াল কথা বলিস না কিন্তু, তোকেই তো আগে রাখবো।
বাংলায় কথা বল যাতে না বুঝতে পারে কেউ। অত
ও বাবা, বাংলায় যেন কেউ নেই ওখানে।
কেউ নেই মানে
অমিত মিত্রকে পাঠিয়ে দেবে, বলবে তারপরে
আরে নাম নিস না,
এবার নামও নিচ্ছে,
আবার নাম নিচ্ছে। কি অবস্থা!
একই বলেছে যে এনকে বলবো,
দেখা গেল পাঠিয়েই দিল। ট্রান্সলেট করো কি কথা
মানে যদি লোকটা নাও জানতো তাও এবার হিন্ট দিয়ে দিল।
হ্যাঁ এখন আরো তুই বল।
এটা ইউটিউবে যখন যাবে না আমি এগুলো
দেখবো, সবাই দেখবে। দেখ দাঁড়া, 1 মিলিয়ন ভিউ চলে আসবে এই লেকচারে।
1 মিলিয়ন
শুনছি মন দিয়ে।
তোদের মতো ছেলেগুলোর জন্য
দেখাতে আদতে
কেউ দেখবেও না এইসব। আমি তো দেখি প্রত্যেকটা রেকর্ডের লেকচারে কোনো ভিউই নেই, 5টা ভিউ,
5টা ভিউ 6টা ভিউ,
এর থেকে বেশি হয়।
ভাই কি বলছিস? আরে এটা স্যার ভিডিও বানিয়েছে, স্যারের ভিডিওতে স্যার মানে স্যারের টিউটোরিয়াল ক্লাসে স্যারের ভিডিওতে কোটা লাইক পড়েছে, কোটা পড়েছে, সেটা নিয়ে আলোচনা করবি? বাবা ভালো।
জানিস কি সাবস্ক্রাইবারও আছে স্যারেদের?
আমি করেছি সাবস্ক্রাইব।
তাহলে
একজন তো আমি।
তাহলে দেখ
অর্চকের মনে হয় এই বছরের পুজোটা একদম ভালো যাবে না, যা শুরু করেছে।
হ্যাঁ এই বছরে তো আর পুজোর ব্যাপার নেই, কিছু
পুজো তো হচ্ছে
বেরোনোর তো
এই
হবে
বছর,
না।
আর হবে পুজো?
হ্যাঁ
সব
হচ্ছে,
হবে, সব হবে।
সব হচ্ছে।
এ পাঁচুদের ওখানটায় যে থাকে ওই জায়গাটার নামটা যেন কি?
বেহালা, বেহালা।
আরে না না, বিহালার ওই কোথায় একটা তো দেখলাম নাকি অনলাইনে পুজো হবে না কি হবে শুনছিলাম, কি
হ্যাঁ,
জ দিয়ে
প্রসাদটা
নামটা,
ঘরে
জায়গাটার
দিতে হবে
নামটাও
তো
মনে
ওটাই।
পড়ে না।
Yeah, so tell me if you have anything else. Yeah,
Sir, I was telling how to proceed for bivariate case as in problem number 6.
problem number
6.
let me see. Tell me what should be the group of transformations. 1 degrees of freedom are available through mu1 and sigma 1, another through mu2 and sigma 2. So what should be the group of transformations?
Should it be same as in the univariate case?
No, univariate case there was only one parameter, mu1 and sigma 1 were there. Now there are two. So that means for y's I can use the second one, different one, right?
Yes, sir.
Y's I can use a different one. So I can use x1. So there the transformations would be x1, x2, xm, y1, y2, yn going to b1 x1 plus c1, b1 x2 plus c1, b1 xn plus c1. So all xi's are b1 and c1, right? And all yi's, because mu2s are there, I can choose different one because mu1 and mu2 here are also different.
Yes, sir.
So yi's I can choose
B2, C2.
p2, y2 plus c2 and so on, right? So that is what I have done over here. This is a problem number. Is that clear to everyone why I am doing that? Because there is a degrees of freedom over here. Here also there is no guarantee that mu1 is same as mu2. So I can choose the same. But now, suppose mu1 was not same as mu2. So suppose mu1 was same as mu2. So what should be the group of transformations? And sigma 1, sigma 2 are different.
Then C1, C2, no, sir. B's will be same and C's are different.
B would be?
B would be different and
C should be same.
Mm. Yes, sir.
That is what you have to remember, right? So this is a problem number, which problem you said?
Problem number 6.
So then it follows the same algorithm, right? You don't have to do anything. Just repeat the univariate thing. Yes.
Yes.
So I have denoted. So first case is when sigma is 0, right? When first case is when mu1 and mu2 both are 0, right? Mu1 and mu2 are 0, so that means C doesn't play any role. Is that okay?
Yes, sir.
So that means I take the transformation x1, x2, xm, y1, y2, yn as r1, x1, rn, xn, and r2, y1 and r2, yn. Is that okay?
Yes.
What should be the group of transformations? You see the PDF. All xi's everywhere sigma 1 will get changed to r1 sigma 1 under r1 x1, r1 x2, and r1 xn, and r2 y1, r2 y2, and r2 yn. And our sigma 2 will get changed to r2 sigma 2. So G bar r1, r2 sigma 1, sigma 2 is nothing but r1 sigma 1 and r2 sigma 2. Is that okay?
Yes, sir.
Okay. So under G, now I said everything should depend on estimate. Under G bar r1, r2 sigma 1, sigma 2 goes to r1 sigma 1, r2 sigma 2. So eta, which is sigma 2 upon sigma 1 to power b, goes to where? Sigma 2 goes to r2 sigma 2. This goes to r1 sigma 1. So it goes to r2 upon r1 to power b into sigma 2 to power b upon sigma 1 to power b, which is same as the original estimate. So that means my a should go to r2 upon r1 to power b into a. And that is what I have done. G tilde r1 r2 a is same as r2 upon r1 to power b into a. Right? So I have got my G tilde. My loss function would be invariant. Let us see whether it is invariant or not. For it to be invariant, L of G bar R1 R2 sigma G tilde sigma 1 sigma 2 should be same as L of A, L of transformed G bar. So this quantity which is R2 by R1 to BA divided by sigma to power, which is nothing but R2 upon R1 to power B into eta. Is that okay? Because loss function was W upon A upon eta.
Yes.
Eta was nothing but sigma 2 upon sigma 1 to power B, which is same as WA by eta. So your loss is invariant. So estimation problem is invariant. So I consider only invariant rules. If I consider invariant rules, delta is invariant if and only for delta of R1, X1, R2, X2 is same as this. Is that okay? Now
Yes.
you can easily see, you can put here Rm as 1 upon mod Xm and Yn as 1 upon, R2 as 1 upon mod Yn, and then you can get everything. So it will become mod of Xm by, so I can choose delta not to be any fix belonging to Di, right? Then delta belongs to Di if and only if delta X is same as delta not X upon UW. Just do this, you can just see that. Way to see this would be how much? How would you see this?
If this is from the scale family, so the estimation problem would be.
It's a bivariate, so you have to see it independently.
Yes, sir.
What I do is this implies that I can choose X1 to be, this would be R1. R1 to be 1 upon mod Xm and R2 to be 1 upon mod Yn.
Mod Y.
So what does that would suggest? That means delta of X1, X2, Xm, Y1, Y2, Yn is same as mod of X1 to power M, because X1 I have taken as 1 upon mod X1, mod of Yn to power B into delta naught of X1 upon Xm, Xm minus Xm, which is a function of W, right? Now W is basically two things, X1 upon Xm, Xm minus 1 upon Xm, Xm upon mod Xm, Y1 upon Yn, and Yn upon minus 1 upon this would be, yeah,
This should be mod.
and then Yn upon mod of Yn, right? Is that
Yes.
okay? That is what it is. Because this, and then this mod of Xm to power M by mod of Yn to power B can be replaced by any estimated scale invariant delta naught, because they are scale invariant. Right? So you can just, the way we did it in the univariate case, this follows. Now there are two parameters R1 and R2 and only two parameters sigma 1 and sigma 2. So G bar I can act transitively because any given sigma 1, sigma 2 and sigma 1 star and sigma 2 star, I can relate them by G bar R1, R2. So that means risk will not depend on this thing. So that means my MRE is delta star X is delta naught X upon U star W, where for any fixed W, U star W minimizes this quantity. This does not depend on sigma. So I can take sigma 1 to be 1, sigma 2 to be 1. W naught of U, W is equal to W. Is that okay? Because these are risk of this function.
Yes.
That would be MRE. Now what happens when both mu1 and mu2 are also unknown, but you are estimating sigma 1? Then the group of transformation would be Rx1 plus C, Rxm plus C, Sy1 plus D, Syn plus D. So I have chosen R and S over here. And what will be the induced group of transformation on the parameter space? R mu1 plus C, S mu2 plus D, R sigma 1, S sigma 2. Now I am estimating sigma 2 upon sigma 1 to power B. So I try to see where sigma 2 and sigma 1 goes to. So under G bar R S C D, mu1, mu2, sigma 1, sigma 2 go to R mu1 plus C, S mu1 plus D, R sigma 1, S sigma 2. So that means eta, which is sigma 2 upon sigma 1 to power B, goes to sigma 2 goes to S sigma 2. This goes to R sigma 1.
S by R to the power B, sigma 2 by sigma.
Sigma 2 power B, S to power R by B eta. So my G bar, G tilde R S C D would be nothing but S by R to power B into A, right? Because this was the A in the original problem. Now I have to see whether my loss is invariant or not. So as G bar R S C D, G tilde R S C D would be same as W of A. A is G bar G tilde R S C D, which is S by R to power B, divided by eta. Eta has become S by R under G bar R S, S by R to power beta into eta. So S to power RB, S to power RB gets cancelled, which is same as W of A by eta. So it is the invariant. So the loss function is invariant. So estimation problem at invariant under G. So now by the same logic as we did in the univariate case, any invariant estimator would be of the type delta naught of xy upon uw, where delta naught xy is any invariant estimator, and w depends on x1 minus xm, xm minus 1 upon xm, xx minus. So I choose C as minus xm, the way we did in the univariate case, right? So MRE is this, where for any fixed w, U star w minimizes this. So that is what it is. Similarly, you can consider the other cases. Is that okay?
Yes, sir.
So it's very algorithmic. There is nothing very conceptual after some time if you have understood the principle of invariance. Very algorithmic. Yeah, any other? So then let us disperse, and then this is all for today. If you have still, I can answer one or two quick questions. So I'll post these today, these solutions, but this will be the last set of solutions which I'll put. You can see that how much I have to write. I can explain this whenever you have doubts. If you want me to write something, you tell me in advance, I'll write it down also for you. If something is, the next assignment onwards, that is what the strategy I would follow. This I'll post today. Is that okay?
Okay, sir.
Okay then, bye for now, and see you sometime next week. So we have to, next week, your exam would be after next week, right? So we'll meet. We'll meet for one discussion hour at least and one tutorial next week. So try to do those problems. If you have a problem in this, we can have extra tutorial if you want. You have to let me know. Otherwise, we'll have a one regular discussion hour and one regular tutorial next week. Okay?
Okay, sir.
Okay, goodbye.
Bye, sir.